we're gonna get started with our next session. Here now we have a presentation from Mike Palecki, who's at the National Center for Environmental Information, National Centers for Environmental Information. I'm sure that's a story. So thank you, Mike, for making the trek out here, and we'll have time for questions afterwards. We have 3 talks in this session, and we're going to go to lunch. So everybody, don't give too many dirty looks to the speakers, okay?
Oh, you can give me whatever look you want. Basically, I'm going to talk to you a little bit about the value of long-term investments in soil moisture. Whoops, I guess I used this one. Okay. So the U.S. Climate Reference Network, you've probably heard of. It's pretty unique in its approach to measuring the environment because we take a redundant viewpoint towards our key primary variables. The first being temperature, air temperature, second being precipitation, and then more recently, soil moisture. We actually put 3 sets of soil probes at each site so that we have both redundancy if a probe fails, or we have also redundancy if the soil conditions are slightly different at different locations around our particular station. And one of the key things that USCRN does is produce really scientific quality data so that people can use it to validate both ground-based systems and satellite systems, and also weather and climate models. And this is the network. It's a coarse network, a sparse network, 114 stations in the CONUS. We do have now 25 stations in Alaska, still putting some in there. But I'm going to talk today mostly about our CONUS stations. We have the 5-minute observations of air temperature, relative humidity, wind speed, but wind speed at the level at which we measure temperature and precipitation, 1.5 meters off the ground. We have soil radiation, surface temperature. But we do the soil moisture and soil temperature measurements in, oh, that's a little louder. Okay. Sorry. In hourly basis. So again, this is one of our special stations. I was just there yesterday, not at the station, but at the Grand Tetons. So I'm tired today. But you can see we have the 3 platinum resistance thermometers in their shields there that are circled. We also have 3 separate wires measuring the weight of the water in our precip gauge, and then we have 3 sets of probes at different locations around that station, usually about 3 meters away in 3 of the 4 cardinal directions. So our role at NCEI, but by the way, the network is owned by the Atmospheric Resources Lab, Atmospheric Turbulence and Diffusion Division. That's part of OAR. But our role at NCEI is to collect and archive the data, quality control it, derive products for users, and provide data access to the community, and also do the science necessary to fulfill those roles. And I'm the lead climate scientist for the USCRN. And this was one of our major early achievements. One of the reasons we put the network in was to prove that all the manipulation we do to all the regular data that has homogenization changes added to it were valid, and we don't homogenize the USCRN data. This is purely what you get from taking 114 stations, adding them together, and dividing by 114. And what's pretty amazing is it matches to 99% level with what we get taking 6,000 temperature stations from around the country. It's pretty good. Precip is a little bit more of a story because we only have perhaps 90% of the variance explained, but it's pretty good too. So, okay, we do this simple math with temperature and the simple math with precip. Thought for today, I do the simple math with soil moisture. How do you do that? Well, if you look at any individual station, and this is a record from the 2012 drought, you can see that soil moisture really is a nice leading indicator of drought, according to the USDM anyway, where the soil moisture is declining rapidly. Before the start of the drought, which is in the black bars, it is rising usually before the black bars start going downhill. So it's soil moisture. In this case, this was 10 centimeters soil moisture, but it's in general a pretty good indicator of drought. So what I've done here is I've taken the U.S. stations and split them into 6 regions. You can see marked by the red lines, northwest, southwest, north central, south central, northeast, southeast. And if 50% of the stations have data, we calculate a regional average. And eventually you'll see that if we have all the regions available, we calculate a national average. Again, these are simple averages, but at the same time, we have a lack of soil moisture information during the freezing season, so there's less of the data available in the northern part of the country than the southern. But this is what it looks like if you take our topsoil, which is 5 and 10 centimeter measurements combined. And you've probably never seen a record like this of the whole U.S. climate reference network or the whole U.S. CONUS area average soil moisture. This is with the volumetric water content. And obviously, some areas are drier, some areas are wetter, but you get a pretty organized pattern. The little gaps you see are when we have the data is missing from the far northern part of the country. But you can see, yeah, it makes sense. But what we do also, and one of the products we provide are standardized soil moisture, where we take the interquartile range and we divide the data through by that to kind of do a pseudo standardization. And this is what it looks like if you average together all the standardized data. Again, you can see the big drought in 2012, early in the history of the network. You can see the ups and downs over the years, although there's a little upward trend if you really squint and take a look at it. Not a significant trend, but yeah, a little more. Precip perhaps is affecting things, despite the fact that temperature is also increasing during that period. I also took a look at 20 centimeters just to see if I was insane doing the topsoil. And again, you get a very organized pattern of looking at the volumetric content being averaged together. And you do indeed see a very similar pattern in the standardized data. You see the big drought in 2012. You see ups and downs along the way, some wetter periods in the later part of the teens, and then it kind of levels off a bit. All right. So yeah, I mean, what's interesting is we're coming to the point where we can actually start looking at trends in soil moisture as part of understanding how climate is changing, how it affects people and regions, and we can do it by regions too. The other thing we can do is I just took a 5-year period that was after the 2012 drought, 2013 to 17, subtracted it from 2019 to 2020, and looked at what the seasonal cycle is doing. You can see that earlier in the spring, it's actually been a bit moister. These are anomaly differences, so these are pretty small. A 0.1 or 0.2 is pretty darn small, but it's still showing a substantial moistening during the spring season, possibly related to the extra precip that's been also noted during that time period. You can also see it's a little drier toward the beginning of fall. Perhaps you can relate that to the ongoing increase in wildfires, especially in the western U.S. And you get the same or similar result with the 20 centimeter anomalies. If you do that comparison, you do see the wetness in the springtime. Obviously, we're not showing winter time because we don't have all the regions during the winter, because the three northern regions are not showing soil moisture data from that time period. All right. We can go and look at the regions. I'm only going to show one region just to show that, yeah, you do still have an organized pattern of information. It's a little more ragged, and the Southwest is actually our probably our most problematic region if you look at the regional results. But you can see some years you do have more wetness, other years more dryness. Overall, of course, we know that there's been drier periods during this period of time especially the southwestern part of the Southwest. Remember, this goes all the way over to New Mexico, so that compensates a little bit for some of the western drought. And you can do the same with the anomalies. Again, you can see some of the drier periods, like 2018 or so, some of the more recent dry periods in the early 2020s, but basically, and of course the recent much wetter period. Uh, but you can actually start looking at regions also on this basis. And of course, you can do this with individual stations. So it's important to have a long time series to do this stuff. Now, on the other hand, most of our users are not looking at soil moisture for climate change. They're looking at for other more practical reasons. So the rest of the talk, we'll talk about that. Oh, I forgot. I did do the difference thing here. Also, again, little, now this is anomaly. So even if it's a small amount of actual change in soil moisture in the spring, the anomaly is pretty good, actually. You can see it's a little drier midsummer. Maybe there's a little wetness before you get to the much drier part of the year, which is in the fall, in the fire season. All right. But okay, now what I really wanted to start with was I get these reports from ResearchGate almost daily, a couple times a week, where people have used our data to do something. In this particular case, they're doing some work with SMAP. And you can see they've referenced three of our papers, the two of which that are most important here. The bottom two are indicating those are the ones that we like people to use when they're using our data. And basically, CRN's really an engine for climate science for many applications. In FY23, we had 12 million individual downloads. If you go to Google Scholar, you'll see 440 references to the main data citation, 308 to the soil data specifically. But unfortunately, a lot of the people that use our data don't recognize that we like them to display those references in their papers. But we also, produce our data and give it away to put it in other places like our Global Historical Climatology Network data sets, International Soil Moisture Network. And you can see actually when you look for a reference to USCRN as opposed to the actual, paper reference, there's quite a bit more use in the literature for our data. And you can see, gigabytes of data be downloaded. Now this includes all of our daily and hourly products all have the soil moisture data in them. So that's part of this picture. So our key role, I think, if we were to look at it in the broader strokes, is validation. It's been used to validate certain in situ networks, as I showed with that first temperature diagram. But more recently, it's been used a lot for satellite kinds of observation validation. And of course, the NASA SMAP was one of the main users of this, but also a whole bunch of other data sets related to soil moisture, like SMOS and AMSR2 and so forth. There will be others if we continue to have a full-blown network. Um, Reanalysis and weather models have used our data to validate their results. How they calculate soil moisture is very important to how they calculate the climate and the weather above. And then finally, land surface models are probably one of the bigger users of our data. At least 18 different ones have used our data for comparison. The National Water model or U.S. Water model of the National Weather Service used it also. Uh, Again, they're not putting this data in the model itself. They're using the data to validate the results calculated within their models. And so without having our network, there'd be poorer for it. There's, of course, mesonets. There's, of course, the SCAN network. But SCAN network is in largely agricultural settings. We are in natural settings, as natural as you get anyway for most of the U.S. And so it gives you a much more interesting kind of perspective on the different kinds of responses of climate to soil moisture, et cetera. So again, just so if you're not familiar, we have monthly data. We don't put soil moisture in the monthly data, but the daily and the hourly data sets have soil moisture in them, and lots of other variables you can use to validate your models if you're modeling soil moisture. And of course, we also have specialized products with the climatology of our soil moisture and soil temperature at our stations, as well as standardized anomalies. We have drought indices that we create by looking at weekly running averages so that the drought monitor authors will perhaps use these when we actually finally get around to mapping them. But right now they're just data, but you can look at the anomalies for that week. You can look at the fraction of those hourly soil moisture values that are below the 30th percentile, above the 70th percentile. So it works on the wet side too. And we also have some heat exposure stuff too. So in conclusion, USCRN's really a tremendous resource for validation of multi-million dollar and billion-dollar satellite and modeling systems. It's really a very cost-effective set of data to have, especially our soil moisture data. It's an endless source of ideas for climate analyses, and you can actually use the data to, look at how your network's working in certain areas of the country. I think we're just beginning to tap USCRN for climate change studies. These longer time series have an advantage, and we really do encourage and hope that the collection of soil moisture data will continue into the future. And of course, this was the title or cover of BAM's quite a long time ago, celebrating our 10th anniversary. We're all well past 20 years now with CRN. So thank you very much.
Do we have questions for Mike?
Yeah, I, as a person who really values all this infrastructure and monitoring and thinks it's wonderful that we're making all this progress, and I don't mean to make this a political question, but I can't help but be aware that we may very well have a new administration in January who, the last time they were in office, sort of had tried a poorly coordinated but systematic attempt to disassemble anything related to gaining information about our changing climate. And such efforts might be way better coordinated coming up. I'm wondering, what people are thinking in your agency, and plans for trying to preserve and maintain these capabilities.
A lovely question. Um, well, I cannot speak for my agency, but I can speak for myself that there is concern, obviously, that uh, not only for specifically targeted removal of climate change related things, but also for just a general poor outlook for the budget if certain changes occur. You can kind of look at the House markup and see where, you know, our my particular location's budget has been, uh, let's say, marked up at lesser levels than the administration requested. However, I would say we can only continue doing our work until we're not able to. And that's the attitude that we're taking. Yeah.
I want to add a little. It, so the language can be a problem sometimes. So climate reference network might be an issue, but the National Coordinated Soil Moisture Monitoring Network started in 1718. It was the initiative. The Upper Missouri River Basin started in the same time frame. And it's a lot about the messaging of what is the need or impact of this data, which you're talking about. And if you can show a monetary value to the data, that's our path forward. It was understanding drought from farmers and flooding. It was flooding that caused the Upper Missouri River Basin initiative, and drought was what the NCSMM came from. So if you can demonstrate a real need that has a financial outcome that we need to address, that's a good way to do it. We just have to watch some of the language and make sure the message fully gets forward on that.
Yeah, I'd agree with that. We used to be the National Climatic Data Center. Now we're the National Centers for Environmental Information. That change occurred in 2015 in anticipation of a previous administration.